Hello, lazy chemists, and welcome to this brief lecture portion on bond energy. And this lecture is just going to be really brief on bond energy because we don't have to cover all too much on it. However, in this section, it does want you to know a couple of things about bond energy, in particular how it is affected by bond length, because this is the bonding section. Okay, so what is bonding energy? And bonding energy is the measure of bond strength in a chemical bond, and it is known as the energy or heat required to break one molecule into their individual atoms, or to actually break that bond. So how much energy is required to break that particular bond? Okay. And what determines this? The thing that determines this is known as Coulomb Force, or it's more like Coulomb's law. And this is a law that I want to go ahead and get you guys used to right here, where it's going to essentially state that force, and in this case this is going to be electric force, is going to equal K, which is, this is just some constant, and this is going to be the charge of atom 1, the charge of atom 2, and all of this is divided by the radius squared. Okay, so the things that are really affecting the size of the force are the charges of different atoms. Okay, so charge between atom 1 and atom 2, and then the distance between them. Okay, and the smaller the distance between them, the greater the force is going to be, because this is dividing it out here. Okay, so that's really what I want you guys to get most out of here, is that the smaller the bond length, the greater the force between these two atoms is going to be, the greater amount of energy it's going to take to do rip two atoms apart. And this formula here is going to be one that, using it to explain a whole bunch of things in terms of force of bonds and how much bond energy is released is going to be important. Okay? So Coulomb force is important. When we calculate bond energy, especially in a reaction, we're going to talk about all the bonds that are broken. So for instance, in the making of HCl, we would have a bond between the two H's, a bond between the two chlorines, and we would make two HCl bonds. Okay, and then here you have some approximate bond energies right here. One thing that I want you to note is that because hydrogen is so small, it's going to have a very small radius, therefore its bond will be small, which is why it ends up having such a large bond energy right there. Alright, so just remembering that bond length and the size of the bonds is going to be really important for us going forward. Okay. In general, and this is just a quick review on bond energy, we say that in order to break a bond, it takes energy, and that energy is released when a bond is formed. Okay. And this one's just a more formal, definition here, but it takes energy to break a bond, and then energy is released when that bond is formed. In general, we go ahead and measure a bond length by breaking apart gases that have a particular bond that we're interested in, and then using joules to go ahead and calculate that. The longer the bond length, the smaller the bond energy, which is, just the basics of this going forward. Really keeping in mind that Coulombic force and thinking about that R squared, that radius between the two atoms, is going to be the main thing here for that one. Okay. And then this is just talking about the difference between ionic and covalent. And usually, this is something about, having the right electronegativities. In general, if it's a magnetic metallic compound versus a non-metallic compound, that's what you want to go ahead and go for. I don't think that they go into this any much different. Okay. Alright, And that's just a basic review on bond energy. Again, one thing that I want you to make sure that you double check is that you have this compound right here. Remember, this is force, this is the energy of a bond. Charge 1, charge 2, over radius squared. Okay? Or just the radius. Okay? This part right here, more often than that, not. This is going to be the most important part for our formula. Alright? That's going to close for this lecture. I know it's pretty short, but it just has to be a brief review. And you'll go ahead and read the chapter and get a little bit more information and hopefully see a couple more examples. You all have a good one, and remember, be lazy.